as I'm moving along here, as I'm continuing to improvise as we move along, I think I'm going to make a decision here. So the idea was to put in all that into here, and I think it would fit, but it would. The problem is it's going to require a lot of custom brackets, and it's going to be kind of difficult. The more I look at it, I mean, there's room. It's just the amount of engineering or the amount of custom brackets that would have to be done to get this to work. I mean, it would have to be basically 3 levels. We'd have our bottom level down there, which is the easy part. That's going to be super easy. But there'd also have to be a level in the middle. There'd have to be a second level, and then the third level would be up here, and then there'd have to be like kind of a level 2.5 over here in the front, because our hood, you know, is right here, so it comes down. So you wouldn't be able to run them all the way across. So there'd have to be kind of a mid-level right here. And so we'd have to drop some sort of custom bracket down and then have our decking go across. Plus that second level, basically, in order for it to not overlap with our third level, which would be, the third level would be right up here, would have to either have those cells rest right on top of the cells below, which I don't like that idea at all, and that's really how it's ending up looking like. So basically, what I'm getting at here is we've designed this to have 3 96-volt packs. So this is one pack right here, and then this is the other pack, and then of course the third pack is already installed in the back of the car. So I think what we're going to do is we're going to cut this in half and basically just put in this right here. So thus we'll have 33% less battery, but because without all the extra brackets and stuff and the weight of the battery modules alone, we're looking at probably be about 150 pounds lighter. So our range is going to go down, but we'll get a little bit back because it will be lighter. We won't be pushing as much weight, plus the acceleration will be a little bit faster. And so I think that's what we're going to do here. So here's what we got now. Built my decks for my batteries right here. We got a lower one and an upper one. As you can see, it actually worked really quickly because it was so easy. I mean, all of the foundation points are already in existing positions there, so it's really just a matter of measuring some wood, cutting it, and getting it in there. So now we're going to bolt it down. I'm going to attach some bolts underneath of it to secure it. This is what it looks like down here. Now we do have to take them back out and paint them, but other than that, we're good to go. That took about a whole hour is all that took. I would have been on this thing for like probably 3 days if I had to do it, if I was going to try to put the other batteries in. So here are the 2 6-cell modules mounted in the car now on the lowest deck right here. This is a pretty straightforward install here. Have to be careful not to put your back out. Picking up those 29-pound modules, you have to kind of lean over here. Be careful not to lean down there too much. But that is pretty much ready to go here. I've been trying to keep the modules, I always have like about a 3/4 inch gap. So I mean, I could have put them together, but I figured that any kind of additional cooling would be better, you know, to have these things, since these are 100% air cooled, so there's not going to be any kind of water cooling, obviously. So anything I could do to get a little bit more airflow in there is helpful. Alright, so here it is right here. Upper deck is pretty much done. We just have to do the final connections going out now. Close the loop on the pack and then connect it to the backpack, which is what those cables are right there going back to. Alright, we're back on our project 5 months later. I had a lot of little things. First of all, we had to wait around for our motor to arrive and some other components, and then I decided, well, while waiting, I may as well finish up my renovation of my house, and so that's what I ended up doing. Thought that was going to be about 4 weeks, turned out to be about 6 weeks. And then summer came, and then, you know, one thing leads to another and another and another, and then so decided to do a whole bunch of other projects and got a whole bunch of everything else done. And so anyway, 5 months later, we're back on it now. So now the good news is we should be able to focus on it and get it 100% done without any interruptions, which is the best way to do it. This is our motor. It's an HP EVS motor, manufactured in the US. It's a very nice, high-quality motor. And as you can tell, it's pretty compact. It's only about 7 inches wide, weighs about 60 pounds. And this is our transmission right here. And so, as you can tell, our motor is basically going to fit right where our transmission used to be. So that's kind of what I got lined up here right now. And so the magic happens connecting it to the drive shaft. You have to mate, you know, the new stuff to the existing. So this is where it's all going to happen right here. Once you get this guy right here, you have to get the right size and everything. There's literally like hundreds of these different sizes. And so it slides right on here nice and tight. And this is how our shaft arrives right here, as you can tell. So this kind of just slips on here nice and precise. And then you have to buy this here key material, high-strength steel key material. It's a separate thing I had to track down. And so this is 3/16. And so it goes in here nice and precise. Keys in there really nice and tight. And so it's nice and just fits in there nice and snug. I mean, just you know, absolutely hardly any play at all. I mean, it just goes in there nice and tight. It almost can go in there and just leave it like that. But so the real key is, this is our new stuff right here. That's our old stuff. So all we really have to do is make this right here fit onto here. So what we're gonna have to do is we're gonna have to take this old one off. This little end piece right here. And once we can make this with this drive shaft, that's where the magic happens, and that's where, from that point onwards, everything's going to be very, very straightforward. I forgot to tell you how much the horsepower and all that stuff is. So this is our chart right here. So 96 volt system, 650 amps. And so the green line is the torque, and the red line is the horsepower. So as you can see here, it puts out about 82 pounds of torque at 0 RPM, so that's going to be quite a bit different than the original motor or the original engine. The original engine it was, you know, a very peaky engine, so it's like you had to rev it up to about 8,000 RPM to get any kind of power out of it, and it only put out about 60. Well, officially 63, but it's probably more like about 70 horsepower or so. But that's like at 8,000 RPM, so 8,000 RPM's way over here. So this thing has 82 pounds of torque right off at 0 RPM. Of course, there's no first gear transmission, so we don't have any reduction gear. So it's basically, you know, direct drive. So that's going to kind of counteract that as well. I think it's going to be very interesting. I think it's going to all balance out really nicely. And then as we get up to 5,000 RPM, it gets about 65 horsepower. So it puts out about the same horsepower, but the torque is considerably more. I finally got this bastard off. Thought that was going to be a little bit easier. It was not very easy at all. It was pretty much stamped in there pretty good. There were like little indentions pressed in here. I don't know if you can see that right there. You can kind of see that there's little pieces of metal right there. That were it was like it was pressed in there on both sides. And so I used a shop press, and then I also used some sockets to finish hammering it out. But you have to hammer out both sides, so you have to basically nudge one out, and then you have to turn it over. And then you have to hammer on this piece, because you can't hammer on this again. You have to hammer on this piece right here to hammer out the other side. And then you have to kind of wedge it with a pry bar and all that. And just, man, it took forever to get these things out right here. So anyway, but it's done. That took way too long to do. What I'm going to do now is I measured the inside here. It's about 21 millimeters, and then the other one's about 23 millimeters. So what I'm going to do is I'm going to take this whole kit. This is discarded, but I'm going to have to take this whole kit over to the driveline shop, a place that actually specializes in custom drive shafts, and they could probably hammer this out in probably 10 minutes or something. It'd take me probably 10 hours, because I would have to buy the part. I'm going to have to buy this little universal joint, something that's going to be able to fit 21 millimeter on one side, 23 millimeter on the new side. So it's not exactly matching. It doesn't match this one. It's going to be a little bit customizing. And I don't really, I don't need to take up a new trade or anything. So it'd be a whole lot easier just to take it over to a drive shaft place There's one not too far from where I live, so I'm going to go ahead and take this in there and see what they can do for me. Okay, so with the drive line at the shop right now, it's going to be about a week for them to modify it. It's going to actually have to be cut and welded on there to get the yoke to match. At least that's what it appears that's going to have to happen. So it's going to be about a week in the shop. I'd rather have them do it than me because I don't really want to mess around with it. So anyway, while we're waiting for that, we can continue on with the car here. So as you can see, I put the headlights back in. We have LED bulbs in now. We have the running light, and we have the LED bulbs on the headlights. I left the high beams halogen because I hardly ever use them. It's not going to matter too much. So we got those in, so that's good. And as I was doing that, I was kind of figuring out some interesting. I kind of discovered a few things about the electrical system here, about how it's wired. So that's going to be helpful for our future mods about how this thing is wired up and everything. So. It's interesting. This car is. I like this car particularly because it seems to be everything seems to be logically placed here. So it's pretty easy to see what's going on here. So basically, our power comes from the 12 volt, goes over there to those relays, comes over here. This big fat wire used to be connected to the alternator, and that's why it's so fat. But that could be reduced in size. But I'm leaving it just because it's already here. It's already existing. And then it comes out over here. So basically this white wire with a red line on it is our main. This is all of our power coming out of 12 volt. It's all going into the car over here. And so we're going to be focusing on this right now. Basically dissecting, reverse engineering the electrical system here and figure out everything that's going on. So our fuse box is right here. And that wire goes in and basically powers up that whole thing, energizes that whole thing. And then from there, we can figure out what's going to the ignition and what's not going to the ignition. Like the headlights, for example, we already know that those are not tied to the ignition. The tail lights are not, and the horn is not. But there's certain things that are. So we're making progress now. So what I've done here is I've accessed the ignition switch right here. So we want to be able to know which of these wires are operating when the ignition is in different positions. So like for example, we have a start position which we're never going to need because that would be for the starter on an engine, but we don't need that position anymore. So I've actually already looked at this and I've already determined that it's this black wire with the yellow stripe on it. So I've gone ahead and snipped that wire off here since we don't need that now, and that wire can either be pulled or it can be repurposed for something else. All the other wires I'm going to leave intact here because they're all useful. So the blue wire on this particular circuit right here I've determined is on the accessory switch mode. Power goes through it. And then on the on position, the yellow with the black stripe and then this kind of black with a white stripe are both being active in the on position as well as the blue. So these three wires right here are essentially in use when the ignition is on. So what this has done for us is this is determined now that we'll be able to splice into these now and then have a wire come out. We can hook up our new devices directly into these depending on how we want it to operate. So if we want to work in accessory mode, for example, the blue switch would be the blue wire right here would be the only choice we have for that. And I don't think I'll have anything in accessory mode. But these other ones, black and the yellow, will be in the on position only. And I think for our coolant pumps and our vacuum pump, that would be good to tie into those. So that way, when we turn the car off, it turns off those pumps, so they don't run continuously. So that's basically what we've got here. That will be the leads for our relays. So there won't be much current going through it, but we will have to have some sort of signal. And that will be our signal right here. We'll be able to splice into that and then run to our relays to turn them off or on with the ignition. So that's what we learned from that. And then over here we got this is our, all of our fuses are going through here. So all of our circuits are coming in. So I've determined that this is all live right now. I mean, there's wires coming in and wires going out, and they're downstream, I guess, is where they're being tied back to the ignition. So some of them are going. Sorry about that. Some of them are going back to the ignition for the circuits that are on the switch, and then there's other circuits that are not being switched at all, like the headlights and the horn, tail lights, brake lights, stuff like that are all not being tied to the ignition. They're actually on all the time. So it's just a matter of kind of figuring out here a little bit more here as to what we want to, which circuits here we want to repurpose. So what I'm going to do now is we pretty much know that there's no fuel injection, and we know that there's no radiator fan. So I'm going to take those two circuits right here. This goes on like that. So we're going to look at these wires right here. You can see that there's a power supply coming in, supplying both of those two circuits right there. Right here, this white with the green wire. I've already run a meter on it, so I know that's live right now. So we have a couple wires coming out. There's a blue wire for the one circuit, and there's a black with a yellow stripe on it for the other circuit. So what we'll do now is we'll pull each fuse out, since we already know that everything is operating on the car. I've already tested everything's working. That's here. I mean, the radio, the lights, the horn, turn signals, rear defroster, everything is basically working. Now, one thing we don't know, according to this information we have here, not everything is on here. So, like, for example, I don't see the power windows on here. We do have power windows. I don't see the rear defroster on here either, so I don't know which circuit that's on. So some of these are being daisy chained together here, so we don't really know, so I can't just sit here and automatically assume that the radiator fan, the 30 amp circuit right here, which we're not using anymore, we don't know. There might be something else on that circuit. So before we go any further, what we're going to want to do, before we start snipping wires, in other words, we want to make sure that that we're not overdoing it here. We're not going to cut wires before we test them first. So what we're going to do is we're going to pull one fuse at a time, such as this one right here, fuel injection. We know we don't have that, but what else is on that circuit? We don't know. So what we're going to do now is pull that one fuse, turn everything on, and make sure everything is still on, and proceed forward one step at a time. So now we're back on the front of the car here. So we have all these relays that are in position here. So we have basically 5, and then there's another one over here. So 6, 5 plus 1. So what I've done is I've already traced one of them back. This one right here that was on the side here, I've already traced this one back to our radiator fan. I was able to trace the wires back by the color code on them. And so I figured that one out. So that one goes back to our radiator fan. So I've always written all my information down for the interior stuff, so I know where all these are going now on the inside. Pretty much I know where everything's going. There's a couple mysteries. The coil wires and then the fuel injection wires, I think, are the only ones that are going out to something, and I suspect that that's what this is. I think that one of these is probably the AC, one of them is probably fuel injection, one of them is maybe fuel pump maybe, and then another one might be the ignition coil, and then we'll have whatever this one is. So I'm not exactly sure which one's what. But I suspect that none of these relays are being used in the car currently. So we'll be able to repurpose these relays once we take them out if we don't need them. Like I know that this one, for example, I'm going to use for the heater, because I do need a relay for the heater. And that's what we're going to use. We have our power going in. It goes in to this side right here. That's directly connected to our battery, 12 volt. And then we have this wire coming out on this side, and that goes around, wraps around, goes out here. So that's our white and red circuit. So that goes into the ignition key position and basically comes out after that. And then we have our, we have a couple of circuits here, and these are actually both being used. There's actually a white and yellow circuit right here, and there's a white and green circuit right next to it. And both of those go into the fuse box, and the white and yellow circuit controls these or actually this side right here. These 4 circuits right here, the headlights, tail lights, horn, hazard, and that's the stuff that's on without the ignition. That's the white and yellow circuit, so that's this guy right here. And then there's a white and green circuit right adjacent to it, and that powers our old radiator circuit, our old fuel injection circuit. And then it also powers the power steering, which goes to nowhere currently. And then there's also another fuse down here below. It powers that one too, which I've identified that one as not doing anything either. So that one's avoided now too. So basically the white and green circuit is not in use currently, but I'm going to be putting these back into use here when I add my heater and my heated seats are going to be on that circuit. So we will be keeping these in position. And then there's the one next to it, which is a real mystery. So we have a white wire right here. It's white only. So that's the fourth circuit. And that comes in here. And the problem is with that, I've traced it back. It goes into the interior compartment of the car here. So it goes in over here. I can actually trace it right there. It's one of those wires there. There's a white, and there's the white yellow and a white green. And it somehow goes over there, but it does not come out on the other side of the car, which is kind of interesting. So unlike all the other circuits that trace back, a white and green circuit right here, we've got those three that come out right here. And then a white and yellow circuit goes up there. A white and red circuit comes up here to the ignition. But the mystery wire is the white wire, which doesn't appear to come out here at all. So it's kind of a mystery what that is. It's a 60 amp fused wire. It's a big fat wire. So all that could be is it must have something to do with the heating and ventilation system. Either it's air conditioning, or there might be a possibility that this car has some sort of additional heating element or something in there, maybe for the defroster or something. I don't know. It's very, very strange, very weird. I haven't been able to figure out what's going on with that at all. It's the big mystery. More interesting information here. So I'm tracing these wires back and everything. I'm marking what's happening here. So interesting that this one right here, which was right here, this one has power going through it on 3 different circuits here. So I don't know if something's short-circuited maybe or something, but it's on. It has power on it no matter what. And yet I've unplugged it and it's affected nothing. I've checked everything. All the circuits are still functioning. And then this one over here, it has 12 volts going through on one side, only when the ignition's on. And that was the one that was really hot. So it was nice and hot, but when you disconnect it, it doesn't do anything. So it was on when the ignition was on, but it wasn't doing anything. It was just on, producing heat. So basically just drawing current out of the system and for no purpose. While the other ones remained really cold. And then of course, this one right here, we determined that this is actually the horn. So of course it's not hot because it's not on, but as soon as you push the button on the horn, then it activates the relay and then it instantly turns the horn on. But anyway, those are clear to be cut off here, so we'll go ahead and do that. This one you'll have to be careful about because it is live, so we'll have to make sure we disconnect our battery first before we snip it down here. I'm thinking, since we have this mystery wire here, the white circuit, this one right here, that doesn't do anything as far as I can tell. And we do have a fuse for that one. There doesn't seem to be any reason in the world I can see that we can't just go ahead and shift our white and red circuit from here over to here, because we already got the power coming in on the back here. That's going back to the 12 volt. We leave that alone. There's a bar going across there, so it supplies power to all 4 of these circuits here. This wire right here is the wire that I was looking to replace anyway because it's excessively big. This was connected to the alternator. It had a dual purpose, and then here it splits into a different thinner wire, which is actually what leads us back to our white and red circuit, which is our main circuit that goes into the ignition. So what I could simply do here, since it was kind of a thing that I was thinking about just for cleaning it up a little bit, I was going to take this fat wire out. So we could go ahead and do that, and I think what we could do is we could just repurpose our white wire. We know that the white wire goes all the way into the car. We could pull it out and then just simply reroute it, pull it over here, and then mend it right here as where this blue is right here. Just basically remove the fat wire and then mend it to the white circuit right here. Then just maybe color coded with a red stripe on it. And then we have our white and red circuit, and it's nice and consistent wire. And it's already wired up right here, so it's all good to go. So all we have to do is basically take this whole thing apart, which I was trying to avoid to do, just because it's already, it's already done. I mean, but now that we've taken it to this level, I mean, it's stock, I guess is what I'm saying. It's stock. But we know there's a lot of extra wires in there. And the other thing that I'm noticing here is that, I've cut off a lot of these wires here. Now, some of these were live. Some of them are connected to stuff. So, like, it is possible that, in some sort of scenario where these things could start to touch, maybe moisture or something, or they just get bumped around and they start to touch. They could literally short circuit the system here. So I think it would be worthwhile, as much as I wanted to avoid this, to go ahead and just do what we did on this other side over here, which is, we've already cleaned it all up and thinned it all out. So we're going to do the same thing on this side. I think now is the time to do it, I think. It will also, we'll be able to reduce this wiring loom down probably half size, because we're going to be taking at least half the wires out that are in here. Because we got all these open wires here, and I cut off that other one over here, so we've got a couple more. As you can see right here, there's a couple more. And all that stuff, all that's a potential for is short. So I think what we'll do is we'll go ahead and just tidy this up.